Okay, so this is my new proposal for that last interaction strategy. In this case, we do have like voronoi cells, so no longer bubbles, and but they're independent from the inhabitants. So in this case, the little blue circle there represents an inhabitant. So the cells do not follow them, although like if a new person entered the room, then new cell is kind of inserted as well. But not necessarily in this 1-to-1 ratio, but more people, more cells. And then the way that this works is that the cells are constantly interacting with each other, and they're kind of trying to find their position in this place. And as the person crosses a boundary, change the room, that room kind of expands a bit, and the room that was entered, it lightens up by some random amount, while the room that's left, it kind of darkens by again some random amount. So this is kind of what it kind of looks like when people are navigating the space. So another thing that happens is that the amount of movement that happens inside a cell, it kind of determines the color. So when there's not much movement, it tends to have this kind of bluish shade, but as like people start moving around, it starts to getting a warmer color. Like in this example, the person is just going up and down around the room, so it tends to get kind of reddish, but as movement kind of stops, then it starts to going back to the more bluish, calmer kind of color. But then like as soon as the person leaves the room, the room kind of retains that color. Of course, if there is lighting, still in this case just went all dark. Yeah, that's kind of about it. So like as people leave the room, and then we have the cells kind of merge and disappear, so we have less cells, but the interaction remains kind of the same thing. So that's it. That's how I propose these internal partitions to behave for this last interaction strategy.